I today review on the teardown of this eBay find. It was €5 on eBay and it is a vintage Graetz X50 geiger counter made in Western Germany. I guess it is from the 60s, maybe we will find a data code or something inside. So it was sold with this lever pouch, but accessories are missing except for a strap. It is missing the external probe, it is why it was so cheap. But for collection it is good anyway. I did clean it a little bit. It is in quite decent condition, but not tested. So it seems to be maybe for civilian use, not sure. Well, it is military green, but it is a plastic case. And you can see the screws are still sealed, so we will crack the seals on the screws for the first time in 40 or 15 years, 50 years even. So what do we have? So it is Graetz X50. I will zoom in for you. On the side here we have the main selection switch. For now it is off. Here we have a battery test function, well, position. And here we have a first range up to 50 rad per hour or 30,000 counts per hour. Here we are at 1000 rad or 1000 counts. So I believe the two scales are for either you use in fact, it is here. You have a selector for a two scale of sensibility. Or maybe also it allows to switch between internal probe, which is here, or external probe, which is missing. Overscale here, and the last one here, and you cannot turn anymore. This button here is for backlight, it seems. Here we have an adjustment for the needle. So switch between red and black scales. Here we have the battery compartment, which obviously needs a very special kind of battery. I have no clue what you need to put in this. Look at this. So there is a little paper about the checking of the device, but it was set, but the year is not possible to read. It is quite sad. It was calibrated. I was searching the word. It was calibrating at some point, but not possible to tell which year. So a little bit of dust in here. So obviously we need a very special battery here. Quite a weird form factor. Looks like it may be half C cell, maybe something like this. So no idea about the voltage. So I will put this back in place for now. On the bottom we have fasteners for a strap and a screw hole for attaching it to the carrying case. On the side here we have what seems to be a DC input, maybe for charging a battery. On this side we have what seems to be I believe it is for headphones. It stands for headphones in German. And here external probe plug. On the top we have a window with a setting between alpha and gamma oh no, excuse me, gamma and beta and gamma only. So gamma only, you have this cover which is indeed in lead. And here is the little sensitive window for the geiger tube inside. So now I will crack open the seals and we will be able to unscrew the back cover. Okay, it was not too difficult. So, oddly enough, there is a Phillips screw here, and the other ones are slotted. Not sure why. You should use one different kind of screw at one point. So it is a pretty long screw. There is some kind of rubber seal. Then. And it is stainless, it seems, or brass maybe. It does not stick to the magnet. Second one, same, no, even longer, this one, yes. So the short Phillips one is near the headphone plug. Okay, 4 screws are out, and now I may be able to lift this cover. Yes, there is a seal which is in a complete state of decay, and we have this little circuit board. As you can see here, it is in quite bad condition around the battery terminals. So it looks like, yes, there was some leakage from the battery. And we have these nuts, I see 4 of them, which seems to be attaching the printed circuit. I can see the probe here. There are wires everywhere. I am wondering what I need to undo. Okay, so let me grab something. They are this one is a very small nut. The other ones must be 5.5 millimeters. No, 5 millimeters. Yes. So in here you can see part of a seal remained on this side of the cover, and there is more stuff from the battery. So let me try to undo the nuts. So it is not too bad. They are not stuck in place. Here you have little spacers which are just put like so in over the screw threads. So this one is coming off. I see metal body transistors. Where did it go? Here. So at least it could require some repair here. The tracks seems to be in quite a sad condition. Maybe this one is cut even. Here too. A lot of solder flux. For sure it was handmade, this thing. Here I can see potentiometers for the each one of the scales probably. I need to do this one also. Testing to open this thing for the first time. Okay, I do not need to remove the small nut, which is good. So I should be able to lift the PCB. Yes. And here we are. A little bit of cleaning. So as you can see, here we have a mechanism for the scale, the different scales. I will turn with this button. And there is a gear here, in fact, which, excuse me, I need to do it later. So there is a gear here, which is actuating the rotary contact here. Apart from that, we have, of course, the geiger tube in here. Little thing with, it seems we have a lid, a case around, and little openings. High voltage wire here probably. Here the plug for the external probe. This is just the body of the push button for the backlight, which must be made here by this very tiny and sad bulb. Seems to be in quite bad condition. On the other side here we have a DC input, and it is all for this thing. Of course here I didn't totally forget about it, but we have also the galvanometer movement for the readout. So on this side we have the electronics. What do we have? It is in fact very simple. A few transistors, old school diodes here, the rotary contact here with the different scales, some capacitors here by WIMA. So yes, typically 60s or 70s kind of capacitor, this one, but I'm not sure. Oh, here we are. Look at this, here we have a date code. November of 1974. And yes, for sure it is 70s, because when I was children, I got a Faller train from the late 70s, and I remember there was a capacitor like this in the terminal board going to the rails. Electric train, and I remember of seeing one capacitor like this in the contacts. So a little plastic body diode here, and we have the transistors, which are BC series, BCY series, BCY 58 for this one. Plastic transistors here, BC 250, regular carbon track diodes. Film capacitor here by, I think it is Siemens logo. Here one Teflon sealed capacitor, military grade, this one, with a glass insulator at the back, at the end, as you can see here. And in fact it is all for this thing. Some electrolytics here, capacitors. Another mill grade one here, one more, a little more passives here, and it is all, so probably a very simple design as expected. I need to get this back from where it was and put this back in place. Okay, so not much in this, but a nice vintage device. It is a little sad for the seal, but I guess it is rubber, so you cannot do much. I will see if I clean these tracks. I have no clue of voltage you need to power it, because I have 25 volts capacitor here. This one is 6.3 volts, so it can be anything in fact. If it is a battery, it must be maybe 12 volts or something like so. In fact, I can test. I have an idea. There is a battery test position, so if I connect a power supply to it, maybe I can crank up the voltage until the battery test is good. So it is probably what I am going to do now, just after a little bit of cleaning on these tracks and reassembling the device. So I will be right back. Okay, so as I said, I connected it to my lab power supply. So let's turn it on and I will crank up the voltage. 5 volts for now. 10 volts, still no signs of life whatsoever. Maybe the contact down here is not good enough, because the screw seems to be quite rusted. So 15 volts, no, it still does nothing. So I guess we have a bad contact issue down here. In fact, I can try to test this. Like so. I'm going to check with the multimeter if I have something. No. There is no contact whatsoever between the metal plate and the body of the screw itself. It is quite a shame. It is why it is not doing anything. So what to do? It should require to take the thing apart again, but what I will do instead is just make manually the contact, and look at this. Now it is doing something. So battery spannung control is here. I guess this is the correct position it is supposed to be. The lamp works, but it is very dim, and now I hear a high pitch noise from the iPhotex power supply somewhere. I did not even see where it is for the treasure tube. So what is the most sensitive scale? I have 1000. So I guess it is the most sensitive scale. I will get some radium dial and see if it does anything. No. I guess these kinds of devices are pretty useless, because in fact you need really if a needle moves, it means you are already basically dead because of the radioactivity. So it seems it is doing nothing, but I have no. This is quite a weak radium source, and I have no other one on D, like no, right now. But at least it is giving some signs of life. Quite interesting little device. No, it is really doing nothing. It should require a very strong check source, I guess. And first solve this problem of a bad contact between the screw and the metal plate. As you can see, it is pretty difficult to have it doing anything. So it may be a restoration project to do this someday. But it would require to really need the contact working anyway, because I have no clue of the kind of battery you have to supposed to insert in this. And probably it is an unobtainium model of battery anyway. Okay, so it was an interesting little device, not very common, and really cheap from eBay. Thanks for watching, bye bye.